In the previous video, we talked about Lewis structures, and the problem with Lewis structures is that they're only practical for small molecules. So, what we're going to be using most of the course is line structures. Line structures can be a little bit more tricky because they don't show necessarily all of the atoms in the molecule, and they also don't show things like lone pairs, for example. They don't have to. And so Lewis structures are better in the way that they can show all of the lone pairs and all the atoms in the molecule. So it's very easy to see what all is there. But line structures are a lot better overall because they're easier to draw and they're basically going to allow us to focus on the important parts of the molecule, especially with respect to reactivity and things like that. So one thing that Lewis structures also get wrong is that that carbon chain is not actually straight. So here we have those carbons in a straight line. All those bonds are at 90-degree angles. We're going to see that that's actually not the case. These bonds are actually at about 109.5 degrees, and that's because carbons are tetrahedral with this particular hybridization. And so we're going to go into that in a little bit more detail later. For now, what we have to know is that they are tetrahedral. What that's going to mean for our line structure is that we're going to see these carbon chains not as straight lines, but more as zigzags. So for this molecule, we have 5 carbon atoms. When we're going to go draw that line structure, we're going to draw that carbon backbone as a zigzag. And another thing that line structures do is they leave out all the bonds between carbons and hydrogens. So we have a lot of them actually in this molecule. All of those bonds we're not even going to show for our line structure. So for this line structure, we're going to just show basically the carbon-carbon bond. So we're going to have one between 1 and 2, 2 and 3, 3 and 4, and 4 and 5. We're going to be just showing those bonds. So 1 and 2, 2 and 3, 3 and 4, and then 4 and 5. We're making that backbone zigzag to take into consideration that the carbon atoms are tetrahedral. So we left off all of those hydrogens. We've just shown those bonds between carbons. If we had a heteroatom in this molecule, we are going to see some examples like that. Those heteroatoms would have to be shown. So if we have an oxygen, we will actually have to write out the O for the oxygen, for example. We don't show any H's. If that H, though, is attached to an oxygen, for example, we would actually have to show it. So if it is attached to a heteroatom, we have to show it. Other than that, we don't show the bonds to the H's. And the carbons are assumed at each vertex and terminus. So that means at the ends of the molecule, we assume that there are carbons, and then each point in the molecule is a carbon. So that's how we draw those line structures. We're going to be doing some exercises to convert Lewis structures into line structures. One thing we need to talk about, especially because we're going to be talking a lot about carbon, carbon can be neutral, it can have a positive charge, or it can have a negative charge, and those are going to be states that we're going to see carbon in for this class. So these states are when they're neutral, we're going to have 4 bonds. So if we see a molecule like that, what is important to note, we'll just focus on that middle carbon here because that's the one that's kind of changing between these molecules. What's important to know is that if we see something like that, that first one, neutral carbon, that means that we're going to have 2 H's attached there that aren't shown because in our line structures, we don't show bonds to H's if they're attached to carbon. So that's what we would assume for our first structure. For the second structure, we actually see that that middle carbon has a positive charge. And what that's going to mean is that we are going to still have to draw a bond to a hydrogen because positively charged carbons have only 3 bonds, and that's it. That's all they have. So we see that we have 2 bonds already shown. And just to clarify, those 2 bonds are here and here. So that middle carbon has 2 bonds shown, but we do also need to draw in a third bond. And that means that that carbon does have 1 bond to H. For negatively charged carbons, these ones also have 3 bonds, but they, in addition to those 3 bonds, have a lone pair. And so on this particular structure, that middle carbon here, we see it has a negative charge that's shown, and we have 2 bonds that are also shown. That means that we have to draw on 1 more bond to an H that's implied. And what we also have to draw on this molecule is a lone pair. So negatively charged carbons have three bonds and a lone pair. So what that meant for this molecule is we did have to draw in that extra bond to the H that wasn't shown and the lone pairs if we want to see what all we're working with there. So just to clarify, you don't always have to do this, but if you are interested in and working with knowing how many hydrogens are there, which is going to be important for some of the things we talk about, you would have to know that there's one hydrogen and a lone pair for negatively charged carbons and just one hydrogen for positively charged carbons in this particular example. So that's something that's important for the carbon atoms specifically. Normally in class, we would kind of go through this section and then I would give these questions to work on during class. And so what we're going to do here is I'm going to give the questions in this video and then we're going to go through them in the next video. So if you want to write them down and try to answer the questions on your own, kind of looking at what we've talked about so far, the next video is going to walk us through how would we convert those Lewis structures into line structures. And then for the second question, where are all the H's and where are the lone pairs on the structures that are shown.